We are going to continue our exploration of regular expressions by looking at defining groups within the regular expressions, using matched objects, naming the groups, and modifying strings with regular expressions. So let's start off with groups. So individual parts of a regular expression can be identified using parentheses, and these are known as groups. One of the powers of groups is that we can make them optional by putting a question mark after the group. So let's explore this a little bit. So here's just kind of a silly test string that I've defined. I'm going to clear my cells. Oops. Okay, so I have this test string, and I'm going to define this regular expression, which is going to find Python or Perl. And then I've broken Python and Perl into the non-P parts here in a group, which has an OR for Ithon or Earl. So let's make a regular expression object and compile this and find the elements of the string. And what we see is here are the matches that we had. And make this more readable, let's see, do for R in results for print R. For every, so find all returns a tuple, and each element of the tuple is what matched for each group. So you see we have this overall group. So we get the Python or Perl here. And then we have the subgroup, so we're getting the Ithon or the Earl. Okay, so let's look at optional groups. So here I'm going to write a regular expression to find a web address. And so I have trying to find the protocol. And you see I use a character class with an S in it with matching 0 or more characters of it to account for HTTP versus HTTPS. And I'm making this group optional because the question mark follows the parentheses that defines the group. And then I have this, what I'm sure there's a better name for it, I'm calling the prefix, which I'm making optional. And then Python or the domain, which is not optional because there's no question mark following it. And then the suffix, the .org, which again is optional because it has a question mark following it. So let's see what this matches. And if we look back up here at our string, let's see, we have Python, python.org would be our first matches. So we have a Python match with no protocol, prefix, or suffix. Then I get the python.org, etc. So this is going to allow us to find particular parts of a string and do something with those parts. Okay, so far we've been using find all, and it returns the strings and the parts we matched in tuples. But there's a more powerful way of working with what we've matched, and that is to use the find iter method. And there are some other methods if you look at the documentation that will also do this. And it returns an iterator that returns a regular expression match object. Now this match object has a lot more information in it than the tuple of what strings were matched. It contains where, for existence, where the start and stop and span of the string that was matched. And so this will be important for many purposes. So here, so the way we use it is I take my regular expression R1, which we defined right here to match a web address. And instead of doing find all, I'm going to do find iter, and that's going to create an iterator, something that we could do a for loop over. But in this case, I'm going to just individually iterate over it. And the way I get the next element out of the iterator is with the next function. So here I call next, it returns a match object. And let me just split this. And we do a type R. See, it's a string regular expression match. What are the methods that it has? So it has end, position, expand, group, group to dictionary, position, span, start, string, end. So a lot of aspects that we can get to from this regular expression. In this case, I'm going to print the span, the start, and the end, and the first group that was matched, which is Python. And then as I go through each group, which I can index, which I access through an index, so you see this R group I. So the first thing that's matched is the overall match. And then you see that when I did not match anything and I do a group, I get a none value. Let's grab the next one. So python.org. So we can see it's span. It goes from 161 to 171, which I can get either through the span or individual start and end values. And I matched, the overall string that I matched was python.org. I didn't match anything for the protocol or the prefix, but I did get the name and the suffix. Here what I matched overall was http://python.org. So my protocol matched. There was no prefix, but I got the Python and I got the .org. Let's get one that has everything. All right, so here we have the overall string that was matched, the protocol, the prefix, the name, and the suffix. Okay, so what we've done so far is we've defined regular expressions. We've broken those regular expressions into groups. We've made some of those groups optional and some of them required. And as we've accessed them, we've had to remember the sequential order of each piece that we defined. We can make this easier for us or the users by defining named groups. And the named groups, similar to like a named tuple, will allow us to use a name rather than just remembering an index to extract the information we want. So a named group is, we have our parentheses, we have what we want to match, but the first thing we provide in our group is a name for it. And the syntax for this is this question mark P and then the brackets, and this is this F, this is going to be the name of our group. Okay, so named groups, let's see, let's go through here because I don't think that is actually true. Is it? Okay, well, I guess it is. So we can access, here I'm accessing things either through a group index or through a group name. And I got the protocol. But what there isn't is there isn't a group name for the overall string that was matched. So I can either use the index or I can provide names. And I guess one thing that's kind of tripping me up here at the moment is we need to remember that if I come up here, I have 1, 2, 3, 4 groups that I've defined, but Python is always providing a group that's the match, the overall match, which is why we end up with 5 groups that we access through indexing, the 0th group being the whole string that was matched. Okay, now let's write a regular expression to identify a name. And so here I have a pattern for a first name. And so a first name to me, which I'm naming here, the group will be named fname. Starts with a single capital letter and is followed by one or more lowercase letters. Then I have some sort of white space. Then I have a middle name, and I'm going to make the middle name, I'm wrapping the middle name inside of a group, which you see right here, which is a capital letter followed by 0 or more letters, including a period, and then a space. And I'm making this combination of the space and the middle name optional, then followed by a last name, which has a similar structure as my first name. And you see then as I go through my matches, sometimes I get, a missing middle name, which would be a none. But everything's looking good there, except for the fact that Pearl looks like a name, and so does Brad Bob. Okay, so this is just illustrating that sometimes it's very hard to create regular expressions that are really specific to what you're trying to match. Okay, the final topic in this notebook is that we can use regular expressions to modify strings. And what I'm going to do, and that's with this sub method of a regular expression object for substitute. So I'm just going to define this string here that has a lot of extraneous white spaces in it. And then I'm going to use a regular expression to search for one or more white space, replace it with a single space, and then return my text. So here is my original string, and it has been modified by the regular expression to be this much cleaner one.